Hello everyone. In this video, let's discuss about operators. First, let's discuss about arithmetic operators. Okay, we'll start with the program hash include stdio.h int main. The execution of the program always starts from the main function. Let me declare two variables, int a equal to 10, b equal to 5. I can say b equal to 4 or 3 I'll give. Okay. Now I'm going to perform arithmetic operations and we'll discuss what are all the arithmetic operators we have by printing the values directly. So printf, as we know, we have to give the format specifier. I'm going to print an integer value, so I'll give %d comma a plus b. So here plus acts as an addition. So the value of a and b will be added together and it gives the output value as 13. I'm just commenting it. Later we'll execute the code and we'll check the output value. Then I'll go for subtraction. Printf %d. Here we'll give new line so that each and every value will be printed in new line. So %d slash n states the new line. A minus b. Okay, it subtracts the values. So 10 minus 3 it is 7. Fine. Next I'll go for multiplication. Printf %d. I'll go for new line. A into b. Fine. So 10 3s are 30. 30 will be the output value. Now division. So when I go for division, we have two operators for division. One is division operator and another one is modulus operator. Division operator gives me the quotient value, whereas a modulus operator gives me the remainder value. So printf %d slash n comma a divided by b. So here the value of a is 10. 10 divided by 3. My quotient value is 3. 3 will be the answer. Then I'll go for modulus operator. %d slash n comma a modulus b. So here the value of a is 10, b is 3, 10 divided by 3, my remainder is 1. So I'll get the output value as 1. Then I'll give return 0. So these are all the arithmetic operators we have. Now let me save the code and run the code. See, the outputs are 13, 7, 30, 3 and 1. So these are all the arithmetic operators we have. Now let's go for the relational operators. Okay, let me take the same program hash include stdio.h. The execution always starts from the main function. Fine. Let me take two variables, int a equal to 10, b equal to 5. Now I am going to perform the relational operations. Similarly, directly I'll print the value, and here we have to know one thing, that relational operator returns the boolean values, that is either true or false. So 1 it is true, 0 it is false. Printf %d slash n I'll give a equal to b. So double equal to states that comparison operator. It compares both the values. Both are equal, it returns true. If it is not equal, it returns false. So in this case I'll have 0. Let me save the code and let me run and check once. See here, 0 states false. The value of a and b are not equal. Now I am going to check whether both are not equal or not. So for that we have an operator, that is a not equal to b. So here both are not equal, 10 and 5 are not equal, so it returns true. True means 1. Now I'll go for greater than %d slash n. So a greater than b. Check the value of a is greater than b. Yes, 10 is greater than 5. So condition is true. So it returns 1. Then printf %d comma slash n comma a less than b. So check the condition whether a is less than b. 10 is not less than 5. So condition is false. So it gives me 0. So the output will be 0. I'm just commenting what will be the output. Later we'll execute and check. Then I'll go for the next operator called greater than or equal to. So a greater than or equal to b. So the value of a is 10. 10 is greater than or equal to 5. Yes, condition is true. So it returns true, 1. Then I'll go for less than or equal to. A less than or equal to B. So here condition is false because 10 is not less than or equal to 5. So condition is false, it returns 0. Then I'll give return 0. That's all. Let me save the code and run the code. See here 0 1 1 0 1 0 0 1 1 0 1 0. That's all. This is what called as relational operators. Now let's go for assignment operators. Okay, so we'll go for the program hash include stdio.h int main. Let me take a variable int a equal to 5. So here the value 5 is assigning to the variable a. So this is what called as assignment operator. Equal to is called assignment operator. The value 5 is assigned to the variable a. When we talk about assignment operator, the right hand side value will be assigned to the left hand side value. This is what called as assignment operator. So for example, printf %d, okay, /n a equal to 7 I'll give and run the code. See here I have got 7. Now you would have a question. See here first I am assigning the value 5 to the variable a. Fine. Now after the execution of this line the value of a is 5. Now when I am trying to print, here I am assigning the value 7 to 5. So it will override. So instead of 5, 7 will be stored in the variable called a. Okay. Now the value of a is 7. That integer value I am trying to print. So the output is 7. Okay. Fine. Now let's go for other assignment operators. So here we have other assignment operators like a plus equal to 2. So what is the meaning of this a plus equal to 2? It is nothing but a equal to a plus 2. This is the actual meaning. So a value is 7, okay, because we have updated the value of a as 7. 7 plus 2, which is 9. 9 should be the output value. Now I'll go for next assignment operator, that is %d. I'm printing an integer value, so we have to give %d. So /n to print each and every value in the new line. So a minus equal to 2. So in this case the value of a is 9. Okay, 9 minus 2. So a equal to a minus 2. So 9 minus 2, it will be 7. Now I'll go for multiplication. This %d /n comma a equal to a star equal to 2. So here what happened? A equal to a into 2. That is 7 into 2, which is 14. 14 will be stored in the variable called a. Similarly, I'll go for next one. %d /n comma a slash equal to 2, which is nothing but a equal to a divided by 2. So 14 divided by 2, my quotient value is 7. Fine. Next I'll go for modulus. So %d /n comma a modulus equal to 2. So here what happens? A equal to a modulus 2. So 7 modulus 2, my quotient value is 3 and my remainder value is 1. So the output value will be 1. That's all. Let's run the code and check. See 7 9. Okay, a value is 7. Okay, let's comment that a equal to 7. So the output is 7. Okay, 7 9 7 14 7 1. See, this is the output value. Okay, now let's discuss about bitwise operators. So let's take the program hash include stdio.h int main. I'll take two variables, int a equal to 10, b is equal to 5. Fine. So when we go for bitwise operators, before entering into that, we have to know truth table. Okay. So when I say truth table, we have gates and or XOR. So 0 0 0 1 1 0 1 1. So according to this, we have to know what is the value of AND, OR and XOR. So if it is 0 and 0, it is 0 only. According to AND gate, if any one of the input is false, the output is false. Here both the inputs are false, obviously the output will be false. 0, 1, it is 0. 1, 0, it is 0. 1, 1, if both the inputs are true, only then it is considered to be true. So it is 1. Now I will go for OR. According to OR, if any one of the input is true, the output will be true. But here both the inputs are false, so I will have false. 0 or 1, if any one of the input is true, it is true only. 1, 0, any one of the input is true, it is true. Both the inputs are true, it is true only. Now when I go for XOR, if both the inputs are same, it is false. Both the inputs are different, it is true. 0 XOR 0, it is 0 because both are same. 0 XOR 1, it is 1 because both are different. 1 XOR 0, it is 1 because both are different. 1 XOR 1, it is 0 because both the inputs are same. This is the truth table. We have to know this, only then we can know bitwise operators. Now when I give printf %d, I'll give new line so that I can know the different outputs. A and B. So here what happens in the sense, the binary value of A and the binary value of B will be taken. I will be performing bitwise operation, that is bitwise AND operation for all the bits. This is the binary value of 10 and this is the binary value of 5. Now I have to perform bitwise AND operation for all the bits. So 0 and 1, it is 0. Next 1 and 0, it is 0. 1, 0 and 1, it is 0. 1 and 0, it is 0. So the final output should be 0. Okay. When I talk about bitwise AND, if any one of the input is false, obviously the output is false. Let's run the code and check. Let me save the code and let me run the code. See, I have got 0. Now when I go for bitwise OR, %d /n A or B. Okay. So here let's perform bitwise OR now. 0 or 1, it is 1. 1 or 0, it is 1. 0 or 1, it is 1. 1 or 0, it is 1. So the binary value of 1111 is 15. So I will get the output value as 15. Let's run the code and check. See, first input output is 0, second output cut. See, first output is 0, second output is 15. I have got this. Now let's go for bitwise XOR. Printf %d /n A XOR B. Okay. So according to XOR, what does it do? It performs bitwise XOR for all the bits. According to XOR, if both the inputs are different, it is true. So 0 XOR 1, it is 1. 1 XOR 0, it is 1. 0 XOR 1, it is 1. 1 XOR 0, it is 1. So the final output will be 15. Let me run this code. See, the output value is 15. Now I have to know right shift and left shift operators. Okay, let's quickly discuss about the right shift and the left shift operators. So here what I am going to do is I am going to give printf %d /n A left shift of 2. Okay, let's see what happens. So if the value of A is 10, we have to see what is the binary value of A. So the binary value of A is 1 0 1 0. Okay, let's consider it to be 8 bits so that we can understand very clearly. Okay, so here what I have given A left shift of 2, which means I have to move all the bits leftwise 2 times. That is the meaning of a left shift of 2. So here first I will remove this 0. This 0 will be removed out. Now this 0 will be come to this place. Okay. Now this 0 will be moved to this place. Done. Now this 0 will be moved to this place. Fine. Now this 1 is moved to this place. Fine. This 0 is moved to this place. Fine. This 1 is moved to this place. Fine. This 0 is moved to this place. Fine. Now finally I have to add 0. I have left shifted 1 times. Now I have to left shift 1 more time because I have given a left shift of 2. So first this 0 will be removed. Fine. This 0 will be moved to this place. Fine. This 0 will be moved to this place. Fine. This 1 will be moved to this place. Okay. This 0 will be moved to this place. Fine. This 1 will be moved to this place. Then this 0 will be moved to this place. Then this 0 will be moved to this place. Finally, I have to add 0 at this end. So I have left shifted 2 times. So this is the final output value. This decimal value will be printed as the output value. So the output is 40. Let's save this code and run the code. See here, I have got the output value as 40. Now let's perform right shift operation. So right shift is pretty simple. Printf %d /n comma a right shift of 2. So here earlier we were doing leftwise shifting. Now we have to perform rightwise shifting. That's the difference. So let's take the binary value of 10, that is 0 0 0 0 1 0 1 0. So here first I have to right shift the elements. First this right value will be taken and that will be removed. Then this 1 will be taken and that will be moved to last place. Fine. Now this 0 will be taken and that will be moved to this place. Done. This 1 will be taken and that will be moved to this place. Done. Then this 0 will be taken and this will be moved to this place. Done. This 0 will be taken and that will be moved to this place. Done. This 0 will be taken and that will be moved to this place. Done. This 0 will be taken and that will be moved to this place. Done. Then finally I have to happen 0 at this end. So I have right shifted 1 times, but in the program I have given 2 times. So again what I have to do? This last bit will be removed. It will be removed. Then 0 will be taken, that will be moved to this place. Then this 1 will be taken, moved to this place. This 0 will be taken and moved to this place. Done. Next, this 0 will be taken and that will be moved to this place. Done. This 0 will be taken and moved to this place. Similarly, all the zeros will be moved. Now finally I have to happen 0 here. Done. So now this binary value will be considered as the output value. Let's save this code and run the code. See, finally I have got 2. 2 is the output value. In short, you can remember, whenever you are performing left shift operation, the value is multiplied by 2. Whenever you are performing right shift operation, the value is divided by 2. A value is 10. So when I perform left shift operation 1 times, 10 into 2, 20. One more time, 20 into 2, 40. So we have got the output is 40. Similarly, when I perform right shift operation, the value is divided by 2 each and every time. 10 divided by 2, it is 5. 5 divided by 2, quotient value is 2. So I have got the output as 2. Why we are dividing it by 2 and multiplying it by 2 in the sense, the binary values are powers of 2. That is why we are dividing it by 2 and multiplying it by 2. That's all. This is the logic of bitwise operators. Next, let's go for logical operators. Okay, let's go for the program hash include stdio.h. So most probably when we talk about logical operators, we have logical and, logical or, logical not. So when we talk about logical operators, it helps to check whether the conditions are satisfying or not. For example, I will give printf %d, comma, a greater than b and a equal to b. So I have to check whether the value of a is greater than b and a is equal to b. So when you have to check 2 conditions, we can use logical operators. See here, a greater than b, condition is true. 10 greater than 5, condition is true. So it returns true. And a equal to b, condition is false. So true and false. So final output will be false. Similarly, when I go for logical OR, A greater than B or A equal to B. So here what happens? Again I will check the condition. See here, A greater than B condition is true, 10 greater than B condition is true, or A equal to B condition is false. True or false, it is true. So I will get the output value as true. Here you have to remember one condition. When we are performing logical AND, if the first condition is false, it will not check the second condition. Because according to AND, if any one of the input is false, obviously the output is false. So in case when you are performing logical AND, you have to check the first condition. If the first condition is false, the compiler will not check the second condition at all. So here A greater than B condition is true, so it will check the second condition. A equal to B condition is false, so I will get the output value as false. When I go for logical OR, if the first condition is true, so here will false is greater than 0, true is greater than 1. So first condition is true, A greater than B, 10 is greater than 5, yes, condition is true. If the condition is true, I will not check my second condition, because according to logical OR, if the first condition is true, I will get my final output as true only, so it will not check my second case. Now when I go for NOT, what happens in the sense? Percentage %d, comma, NOT of A greater than B. So here first I will check A greater than B, condition is true, 10 greater than 5, yes, condition is true. If the condition is true, when I put NOT, it gives the output as false. That's all. This is the logical operators. Let's run the code. So 0, 1, 0. So 0, 1, 0. I have not given new line, so it is printed continuously. 0, 1, 0 is the output value. 0, 1, 0. That's all. This is called as logical operators. Now we have to know one more important operator called comma operator. Okay. So you have to know one thing. In C language, comma is acted as an operator and also separator. We have to know where it is acting as an operator and where it is acting as a separator. So let's take a program, sample program. Okay. Int main. Maybe whenever we go for declarations, comma is acted as a separator. For example, int A, comma B, comma C. In these cases, it is acted as a separator. Again, I will repeat. Whenever you are declaring variables, it is acted as a separator. Now, I can give int d is equal to 10, comma e equal to 20. So here, comma is acted as a separator because it is separating the variable d and variable e. Is this clear? And also, when you are passing it to functions, for example, I will declare a function, right? Void, I will give outside. For example, I can give int add, int a, comma, int b. So here it is acting as a separator. Here it is not acting as an operator. Hope you are clear with this. Now let's see the places where it is acting as a operator. Okay. Now let's go for operator where comma is acted as an operator. So for example, if I give int a equal to, in brackets, if I am giving 1, 2, 3, 4, in these places, comma is acting as an operator. So here, when I give bracket, first it takes 1, it is acting as an operator, it is considered as a next expression. I'll go for next expression 2, then I'll go for next expression 3, then I'll go for next expression 4. So the value 4 will be taken and that will be stored in the variable called a. So let's take different variable f, because already I have declared a here, that's why. So f, so the value stored in f is 4 because here it is not considered separator, it is acting as an operator. It takes one expressions. One is one expression done, second, third, and finally 4 I have got. This value will be stored in f. Let me print and check percentage %d, comma f. Let me save this code and run the code. See here 4 has been printed as the output value. And also you can give a equal to b is equal to 2, comma b plus 5. Here also it is acted as an operator because first I am assigning the value 2 to the variable b. Now the value of b is 2. Then expression, next expression I am going 2 plus 5, 7. The value 7 will be taken and that will be stored in the variable called a. So when I print, A value will be 7 and B value will be 2. Let's print and check. Printf %d comma A comma B. So already we are printing the variable f. So let me give a space. So output should be 472. Let's run the code. 472. Yes, we have got it. So here it is considered as an operator. These are all the places where we are considering as an operator. So one more example you have to know. So here if I give int A is equal to 1, 2, 3, 4. In this case, when I try to print A, what am I getting? I have to get the output value as 4. Yes, I have got the output value as 4 because expressions are different. Last value will be taken, that will be stored in the variable A. I have got the value as 4. Now, if I give like this, int B is equal to 1, 2, 3, 4. So let me run the code. It will throw me an error because whenever we are declaring, comma is not acted as an operator, it is acted as a separator. So it will throw me an error here. See here, error identifier or open bracket before numeric constant. It is expecting parenthesis before the numeric values has to be open. That is why it is showing an error because in this place comma is not acted as a operator. Here it is acted as a separator. Now I can overcome this in another way, which is first I'll declare the variable int b. I'll declare the variable. Now I'll give b equal to 1, 2, 3, 4. Here it is acted as a operator. Here equal to is one operator, comma is another operator. When I compare with these two, equal to has the highest precedence. So what will it be considered? It is considered as b is equal to 1, 2, 3, 4. It is considered in this way. So the value 1 will be assigned to the variable b. Here the value 1 will be assigned to the variable b and these expressions are considered. So 2 is considered as one expression, 3 is considered one expression, 4 is considered as one expression because here comma is acted as an operator. So in this case it will not throw me any error at all. So A value is 4, that's all. Now I have not got any error here. When I try to print the value of B, I'll get as 1. So A value is 4, B value is 1. So A value is 4, B value is 1. Here it is considered as an operator because in the declaration places, whenever you are using comma, it is considered to be a separator. But here I have declared separately, I am initializing separately, so here it is considered to be an operator. Okay, that's all.